Welcome to EDU World Space.
So in this video, we're going to talk about question 68 from chapter 20, which says, give the Lewis structure, molecular structure, and hybridization of the oxygen atom for OF2. Would you expect OF2 to be a strong oxidizing agent like O2F2 discussed in exercise 67? So it's worth talking about what we did in exercise 67. So exercise 67 asked us to give the Lewis structure, bond angles, and hybridization of oxygen and O2F2. Then we're told that O2F2 is a vigorous oxidizing and fluorinating agent, and we're asked if oxidation states or formal charges are better for accounting for that high reactivity of O2F2. So what we're going to do is go over what oxidation states and formal charges are, then we'll draw the Lewis structure for O2F2, assign oxidation states and formal charges, decide which one of those is better for accounting for the high reactivity of O2F2, and then we'll use that when we're analyzing the Lewis structure for OF2. So what's formal charge? Formal charge is the charge on an atom, assuming that the electrons in a bond are shared evenly between the two bonded atoms. So the formal charge is equal to the number of valence electrons minus the number of lone pair electrons on the atom minus half of the number of bonded electrons. Then we have the oxidation state, where different from where our electrons are shared evenly in formal charge. In our oxidation state, we are assuming that the more electronegative atom will take all of the electrons in the bond. So then the oxidation state for the more electronegative atom is equal to the number of valence electrons minus the number of lone pair electrons minus all of the bonded atoms, not half of them. And then the oxidation state for the less electronegative atom is just the number of valence electrons minus the number of lone pair electrons. So the difference between formal charge and oxidation state is that in formal charge, we assume electrons are shared evenly in a bond, but in oxidation state, we assume that the more electronegative atom is going to take all of the electrons in a bond. So O2F2, we know that oxygen has 6 valence electrons and fluorine has 7 valence electrons. That gives us 12 plus 14. We have 26 electrons overall. So let's go ahead and start drawing our Lewis structure. So we know that our fluorine likes to make just one single bond. So we'll single bond it to our two oxygens, and then we'll go ahead and fill in the octet on our fluorine atoms. That gives us 8 electrons left over, so we can put 2 lone pairs on each oxygen. And that's it. That's all 26 electrons. So now above each atom, I'm going to write the formal charge. And below each atom, I'm going to write the oxidation state. And then we'll compare what those say about the reactivity and whether or not that matches up with the reality that O2F2 is a very strong oxidizing agent. So the formal charge on fluorine. So we have 7 valence electrons minus 6 lone pair electrons minus half of the electrons in our bond, so minus 1. So 7 minus 6 minus 1 gives us a formal charge of 0. And it's the same story for our other fluorine atom on the other side of the molecule. Both have a formal charge of 0. Now for our oxygen atom, we have 6 valence electrons minus 4 lone pair electrons minus half of the 4 electrons that are in the bonded electrons. So 6 minus 4 minus 2 gives us a formal charge of 0. And it's the same story for the other oxygen atom. So the formal charges on this are all 0, which would indicate that this is not a very reactive molecule. It doesn't indicate that strong oxidizing property that we know O2F2 has. But let's see what our oxidation states say about this. So which ones are more electronegative atoms? So in our oxygen-fluorine bonds, the fluorine is more electronegative than the oxygen. So it'll take all of the electrons when we're talking about bonds between fluorine and oxygen. But what about our oxygen-oxygen bond? Those electrons will actually be shared evenly because oxygen can't be more electronegative than oxygen. So those will be shared evenly. So first let's do fluorine. So in fluorine, we have 7 valence electrons minus 6 lone pair electrons minus our 2 bonded electrons. So we have 7 minus 6 minus 2. That gives us a formal charge of minus 1. And same story for our other fluorine atom. Now what about our oxygen atoms? So we have 6 valence electrons minus our 4 lone pair electrons minus, we just have half of this one bond, this oxygen bond. So we have 6 minus 4 minus 1. That gives us an oxidation state of +1. So these oxidation states would indicate that you have a powerful oxidizing and fluoridating agent. It would indicate that this is less stable and more reactive. So the oxidation states are more reflective of the oxidizing and fluorinating properties of O2F2. So when we're talking about how reactive OF2 is going to be, we're going to use oxidation states. So let's go ahead and do OF2. So we know that oxygen has 6 valence electrons and fluorine has 7 valence electrons. That gives us 20 electrons overall. Our oxygen atom is going to be the central atom, and we know that fluorine likes to make a single bond. And then we can go ahead and fill in the octet on our fluorine atoms. After we do that, we have 4 electrons left over, so we can put 2 lone pairs on oxygen. And that uses up all 20 of our electrons. So let's assign oxidation states and see how reactive this molecule is. So our fluorine atom has 7 valence electrons minus 6 lone pair electrons minus both of the electrons in that bond, because fluorine is more electronegative than oxygen. So we have 7 minus 6 minus 2. That gives us an oxidation state of -1. And the other fluorine atom will also have a -1 oxidation state. And then what about our oxygen atom? Well, we have 6 valence electrons minus 4 lone pair electrons, and that's it. We don't have any electrons that are shared with oxygen, since both of oxygen's bonds are to the more electronegative fluorine atoms. So the oxidation state on oxygen this time is +2. So you have an even larger difference between the oxidation states in our oxygen and fluorine atoms here than we did in O2F2. So this would actually be an even more powerful oxidizing and fluorinating agent than O2F2 was. But we're not done yet. We need to talk about the geometry of the molecule and the hybridization. So we know we have oxygen bonded to 2 other atoms and has 2 lone pair electrons. So it's surrounded by 4 things. So we know that when we have 4 things surrounding an atom, they're going to form a tetrahedron. But since only 2 of those things that are bonded to our central atom are atoms, then we have this bent, or in other words, angular structure. And how do we figure out the hybridization? Well, we have 2 bonded atoms plus 2 lone pairs of electrons equals 4. A hybridization of 4 is equal to sp3. So we have an sp3 hybridization on our oxygen atom here.